And we're back. Let's look at rational inequalities. This is going to feel very, very similar to what we just talked about with polynomial inequalities. It is virtually the same with one minor exception. And so this is really good practice for both, like they're so similar. Rational inequality, we're just talking now instead of about polynomials, we're talking about a rational function where instead of an equal sign, we have a greater than, less than, greater than, less than or equal, or greater than or equal. Give you an example here. Basically, we have this rational function on the left-hand side here. With polynomials, we saw that we could only change signs from positive to negative at the zeros, or x-intercepts of the graph. But a rational function could also change signs at a vertical asymptote. Remember, rational functions have vertical asymptotes. Polynomials do not, because they are nice and continuous. They're a nice smooth curve. But a rational function may have a jump where you have to pick up your pen at that vertical asymptote. It's not continuous. So what may happen is you might have something like this function. This is just the basic rational function y over x, where we have a vertical asymptote here. Notice at that vertical asymptote, the function changes from negative. Over here, the function is negative, and over here, the function is positive. There was no x-intercept there that we would find by solving and finding the x-intercept to tell us that it could change, but it might change there, so we have to consider that. These steps are very, very similar to what we saw above, so I'm not going to work through them. I will fill in these blanks here. Setting the numerator equal to 0 will give the x-intercepts, or the zeros, of the function. Setting the denominator equal to 0 could give us vertical asymptotes. Not always, but sometimes. So we'll do that, and then the process is still the same. First step has to be getting 0 on one side of the inequality. That means I have to subtract 4 from both sides. X minus 2 over x plus 3 minus 4 less than 0. My challenge here is that this is not a rational function as it's written. A rational function is a single polynomial over a single polynomial, one fraction. That means I need to rewrite this, which means I'm going to get a common denominator and multiply by x plus 3 over x plus 3. X minus 2 over x plus 3 minus 4x plus 12 over x plus 3 is still less than 0. Common denominator, so now I can combine these into, what is that, negative 3x when I do x minus 4x, and then negative 2 minus 12 will be negative 14. Now I have a rational inequality where I have a rational function less than 0. I will have an x-intercept when negative 3x minus 14 is equal to 0. I addressed why that is in a previous video. You will have a vertical asymptote when x plus 3 equals 0. So x equals negative 3. I'm going to draw my number line here. X equals negative 14 thirds. It may be helpful to think of that as negative 4 2/3. I need to know that so I know where it belongs on the number line. And then -3 is here. That means our intervals, one thing to remember, this is a point on the graph. This is an asymptote, -3. Intervals -∞ to -14 thirds, -14 thirds to -3, and then -3 to infinity. We're going to do the exact same thing where we do some test points. -4 2/3, how about we just do like -10 to make things easier. Between here, let's go -4 and then maybe 0 over here. Plug those into the function, and when I say function, I'm talking about this thing that is a single fraction less than 0. So f of x equals -3x minus 14 over x plus 3. When I plug -10 in the numerator, I'm going to get 30 minus 14 is a positive number. -10 in the denominator will give me a negative. That gives me a result of a negative number. Plugging -4 in the in the numerator is going to give me a negative 12 minus 14. -4 in the denominator is also negative, so I get a positive on that interval. And then plugging in 0, I get a negative over a positive, so I get a negative. I want to know where this function is less than 0. I'm looking for the negatives here. And so that means my solution, write these intervals, -∞ to -14 thirds, union -3 to infinity is where this inequality will be negative, which means that's where this fraction, x minus 2 over x plus 3, is less than 4. Make sure I followed the directions here. Graph the solution on a real number line and write your answer in interval notation. All right, I'm going to erase this point there because I want an open circle there. I don't need an open circle there because it's an asymptote. It's implied that it's an open circle. So I want here, and then, well, I guess if it's a number line, we should probably put an open circle in there because we can't include that -3 for sure. So that green on the number line is my graphical solution. Okay, that's it for rational inequalities. So, like I said, it's very, very similar to polynomial inequalities. You just have that extra condition of the asymptote being a potential place where it changes from positive to negative. Like it did in this example. It changed from positive to negative at -3. So we have to consider that. Be sure to ask if you have any questions about these inequalities.